Data partitioning is a feature you'll find in CloverETL Server Corporate and Cluster editions that lets you run multiple instances of a component or bunch of components in parallel, fully utilizing multi-core or multi-node environments while keeping your graph design simple and clean. This can dramatically increase overall throughput when using operations that take a long time individually, yet running more of them at the same time doesn't slow down the system. For example, waiting for web service API calls, single-threaded calculations, in-memory sorting, or parsing complex file structures. All these will benefit from running in parallel, each on its own chunk of data. Also, data partitioning scales naturally from a single server to multiple nodes of a cluster without you having to redesign the transformation. Let's look at how data partitioning works in practice. In this example, I'm fetching current weather conditions for a bunch of cities. This simple REST API call and parsing of JSON responses takes around 2 minutes to complete. With the API call being the obvious suspect, I quickly tested what happens when I run 2 queries simultaneously by partitioning the list into 2 streams, running 2 concurrent API calls, and using simple getter at the end to get the results back into a single file. This itself cut the time by almost a half. Now, how about running 50 of those? It doesn't look like copying these components 50 times over would be a good solution. That's where data partitioning comes in handy. Instead of multiplying branches as you've seen in the previous design, I'll start with the original graph and set a multiplier, or allocation as we call it in CloverETL, for the components I want to run in parallel. Allocation controls how many instances I want to run, and also, if I have CloverETL on multiple nodes, it controls where I want to run them. In this case, let's go by number of workers and set that to 50. Don't forget to save so that the server validates your settings. Notice I'm getting an error now. The Excel reader will not run in parallel, even though the rest of the transformation inherited my desired multiplier. In order to fix that, I have to explicitly tell Clover where and how to split the data. I'll do that by placing cluster partition component to the same place I had the regular partition in the previous example. Instead of multiple branches before, this will split the incoming records among multiple background workers. I have to do the same at the end using cluster simple getter to collect data from all those workers to write out a single file. Now check this out. This time, it only takes 7 seconds, more than 15 times faster compared to those 2 minutes in the beginning. The cool thing is that you can easily scale this to as many instances as you like, even passing allocation as a parameter should you need to set it dynamically. Also, the layout of this transformation doesn't need to change in any way when I deploy it to cluster sometime in the future. I hope this helps you understand how you can use data partitioning. Keep in mind, you need to be running at least CloverETL Server Corporate version 4.2 or cluster. If you're not, I strongly recommend you getting an upgrade. Just follow the link below. You can use this in many other ways. For example, be sure to check CloverETL's partitioned sandboxes and files if you're processing really large files. Thanks for watching.